Good morning. We are JABR Geotechnical. We are one of the 3 teams that worked on the MTU facilities pathway, along with Joe Engineering, who did the pathway layout, and then also PTS Engineering that conducted the site drainage. I am Amber Ronsman. I'm the project manager for the project.
I'm Bobby Mills.
I'm Ross Ogun.
And I'm Jay Zernia.
An overview of the presentation today. So we're going to start with a little project background that goes more in depth with site layout, demolition, detour, lighting, soil and groundwater details, and then retaining wall design options, along with a cost estimate, schedule, and recommendations. As far as the project background goes, it is a pathway on Michigan Tech's campus in Houghton, Michigan. And it is a pedestrian and bicycle pathway from Phoenix Drive to Cliff Drive. Pathway will provide ease of access between the electrical engineering building to the Great Lakes Research Center. And the areas of study that JABR focused on were site utilities, design parameters, soil and groundwater evaluations, lighting requirements, and then retaining wall design options. Our advisors were Dr. Melanie Watkins, Russ Lutch, and then Jake Gooder from Michigan Tech.
So for the site layout of this project, as you can see, we're on the hillside in between Cliff Drive and Phoenix Drive. And then first off, we started picking out the laydown areas for this project. And then the 2 main parameters we had were they had to be a close proximity to the site for easy access, as well as that they had to be easily vacated by MTU facilities management. So these 2 areas in orange is what we picked out. And then the second area is it's 20 parking spots in blue. And these are blocked off for safety reasons. We felt that with how close those were to the project site, it could pose as a danger to anybody parking there, with demolition going on a pathway right above it. And then the pathway from top to bottom will be about 810 feet. And the relocation of utilities will not be necessary due to the pathway being designed around the steam tunnels. The steam tunnels are the only utility that was going to be in our way. And for the mobilization and site layout estimate and schedule, first, we use the MDOT spec book averages and use prices relative to the UP so we can get an accurate estimate. And then for the mobilization, we found that it'd be $80,000. This includes temporary power setup and equipment and material delivery. And then for the site layout, it was $9,800. And then we included in this was the utility staking, marking everything out before construction, as well as pathway location staking. So when the demolition crews came out and the clearing crews, they know exactly where that pathway is right up the hill.
As far as demolition goes, it is going to be we originally planned for a clear cut, but then revised our decision with that because of permitting issues. So right now it's looking like 3/4 of an acre will be cleared. That's about 3,200 trees. This is with the equipment in mind and movement that they will need on the hillside. This is what we feel would be a comfortable amount to be removed. Then there will also be a minimal sidewalk and curb removal up down by Phoenix Drive. And that's about 15 feet. And then again, the pathway is about 810 feet. So there's going to be some rough grading and removal there. And you can see the proximity of the equipment laydown areas in this picture also. As far as detour goes, we know that the HSTEM building is potentially going to be going on at the same time. So this was also with that in mind. So there will be a potential for a flagger due to high traffic times in the morning and the afternoons of faculty commute. And then this won't be needed necessarily every day, but it will be on a as needed basis. The main detour will take place on Townsend Drive, and that will be also in correlation with the HSTEM building. Then as Ross talked about, there will be the 20 parking spaces removed. We feel this won't vastly impact the faculty, and these will only be temporary, and those will be given back as soon as possible, so that once we move from the bottom of the pathway, they will be able to get back in there. And then again, just the coordination with the HSM building, we will have a digital sign that messages can change on, so that ever-changing planning with the university can be displayed and the route can be correct on there. As far as costs for demolition and temp signage, it came to about $12,500 for tree and stump removal, clearing, and tree debris. We again used MDOT spec book pricing based on averages for the UP. Then the temp signage was a larger number, around $59,000 because of the flagger potential, and then also that changeable sign, along with your typical barrels, your construction entrance signs, and those items, they do add up quickly. As far as pathway lighting, we dug into this because we know the pathway wants to be used 24 hours of the day if needed, and then also in case of emergencies. So there will be lighting on the pathway. We did a calculation based off of lumens and height of the lighting, and looked at typical lighting that's on campus right now and spoke with Jake and what they recommended. So they're going to be about 81 feet apart. There's going to be 10 total light poles. They are going to be LED lighting and Portland cement bases to match those on campus, as that is the typical we are going to start to go with here at Tech. So you can see that laid out on the plan, and they will be all on one side to tie into where the existing utilities are, and a little bit more less to dig up there.
For the soil conditions, conditions are obtained using the soil borne report done in the 1995 for the Dow building. They classify the soil using the USPS system and classify it as coarse graded gravels, sands, little to no fines. We consider these borings were done. Some of them, they are quite distant from some of where the path would be. So it is recommended to do more borings where the actual path would be. Unconfined compressive strengths is about 38 psi. That was determined from the results of the standard penetration test provided in the report. We're also recommended the use of a 32-degree friction angle and a moist unit weight of 135 pounds per cubic foot. And the soil is very permeable because there is little to no fines in it. For the groundwater conditions, the Lake Superior elevation, as you can see, the max and min hasn't fluctuated too much through the years. That was obtained using the U.S. Army Corps of Engineers data. The Portage Canal is around 600 feet, and that was with the north entry buoy from NOAA. The site elevation down at Phoenix Drive is around 615 feet, and up on Phoenix Drive is around 690 feet. The groundwater is average around 600 feet. This is because it stays with the high permeability of the soil. It'll stay pretty consistent with the Portage Canal, which is fed by Lake Superior, and that should stay pretty constant. This will also not affect it should not affect any of our construction, because it stays about 15 to 90 feet below the site surface, and we don't expect where it's 15 feet below surface, we don't expect to be excavating that deep into the soil. Here's an example of the earth pressure diagram. This is including the sloping backfill and surcharge. It does not take into water pressure because we assumed it would not affect that. So for the site cut and excavation estimate, we also use the NDOT spec book average unit prices from 2020, and we increased the prices by about 2% for inflation. And using a superior region prices to get a more accurate estimate. The earth excavation came to about $53,500. The cubic yards were calculated, this is assuming a 15-foot cut along the entire path length, plus a 2-foot cut underneath that for the subgrade examples. So it comes out to about 1750 a cubic yard. For rock excavation, this came to $77,300. This was estimated at $68 a cubic yard. Rock excavation, we assume we might see rock. That's why we also recommended more borings. For the fill and the aggregate base, that's about $52,000 a plant. And that was just about estimating about half the total earth excavation that we need for fill.
All right, now our proposed design for the retaining wall system. Obviously, the retaining wall is a major component of the overall path layout, as it has potential to run across the entire duration of the path from Upper Cliff Drive to the bottom of Phoenix. We actually looked at two different retaining wall options. Not pictured here is the cantilever, the basic cantilever retaining wall design. We actually dug into that and we chose to move away from that design option just due to the overall footprint that it would require for the construction of the process, as well as the price layout and really the slope of the hill and the constructability of that wall system. So upon looking at that design, we decided to move in the direction of a soldier pile with 4-inch wood legging design wall, retaining wall along the entire system. And pictured here, you can see the upper portion of that wall. So we're assuming a 15-foot cut for the path, right? That flat section shows where that path was located. The slope section is where that hill is going to be coming down into the path section. We designed it with a 26-degree slope coming into that section. So once again, this is the upper wall. So it's 15 foot tall with about a 10-foot in the ground section of that beam. We also have a lower wall, not pictured here, that has a 10-foot cut just to accommodate the overall path width on this hillside. Once again, that has a 26-degree slope sloping down from that path. So this is a continuous system and they're connected between the two. But once again, the only pictured here is that upper wall just for the sake of the software that we use. Looking at this upper wall, the surcharge we used for the design system was 200 PSF. And the distance between the beams that was calculated is roughly 6 feet. Now we feel like this might be able to be stretched apart once we get to certain areas of the path, including the steam tunnels. It won't quite require a 15-foot cut at those moments. So if we're looking at 10 or smaller, we should be able to get on either side of that steam tunnel relatively easily without disrupting any of the existing utilities. The beam length, once again, is 25 feet in total, 15 foot above ground, 10 feet below ground. The factor of safety that we used in our design system is a number of 2, which is more than sufficient and pretty basic for design systems of this size. And our total tieback length is roughly 6 feet at a 7-foot marker on the 15-foot wall system. Our bottom wall is a distance between beams of 8.25 feet. This might be able to stretch to 8.5 feet on the bottom wall. Once again, that's the smaller wall with the total beam length of 17.1 feet with 7.1 feet below ground, 10 feet above the ground. Again, this shouldn't disrupt any of the utilities that are existing as we go through the system. And the factor of safety, once again, was calculated to be 2.0. The construction method that would be used on this hillside to build these walls would be the driving vibrating method. And we have that accounted into our estimate further on in the next slide. And of course, the retaining walls, just for the overall scope of it, is really the lion's share of our total estimate. We use the MDOT spec book average unit prices, once again, with prices applicable to the Upper Peninsula and the Houghton area. Our total pile driving equipment on site would be roughly $102,000. This may fluctuate depending on availability and the season in use. The pile point used for each pile would be roughly $40,000. This in total for across the entire length of the path. The steel pile and legging material uses alone would be roughly $344,000. That price is likely to fluctuate due to the steel prices that we're currently experiencing in the market. So that price might shift depending on the time of year and the availability of the market. The anchors used for each driving in at each steel point, it's roughly $158,000. Again, that price is likely to fluctuate with the steel prices that we're currently experiencing. And the precast fascia, this was per request of facilities. This would go on and be the surface that the people would see on the path rather than the wood legging view that's shown in this picture. This fascia would be roughly $281,000, making the total retaining wall price roughly $927,000 in total, just shy of $1 million.
As far as schedule goes, we know it's a large part of the project as it needs to be done more in the summertime due to less congestion on campus. So the project will begin in April with construction, document development and procurement and getting those lead times going. As we know, steel, like we talked about, is an ever-changing item in the industry right now. Along with starting site clearing for around the beginning of May, right after finals for the spring semester and that will take about a week. Retaining wall foundations will then begin, and that will be a larger critical path item for the schedule, starting at right after that site clearing, and then retaining wall excavation will then go on about 3.5 weeks after that 7-week start. And then paving will take about 1 week with the rough grading and then base going down. And then following that and the final touches, finish grading will be final inspection and project closeout. We have about a 1.5 weeks figured for that so that the individuals from the area who need to inspect will be able to come out and have enough time. That will give us roughly a 4-month overall schedule with a little bit of wiggle room in there. As far as an overall project summary goes, you can see the finished design potentially of the retaining wall, as we talked about, some architectural precast. And then the overall cost for the project will be around $3 million. This is for alternate 1, which is our soldier pile retaining wall, as we spoke about before. Joe Engineering has alternate number 2. And the price of PTS Engineering's drainage is included in this number. And of course, you can see the breakdown of the estimate on the side here, with around the largest number being the retaining wall, but then coming in second is the contingency, which is figured around 30%, just for those unknowns in the project, along with retainage following that also being in there. We figured the schedule on 3 crews with about 3 laborers and give or take some operators, so that they aren't all necessarily going to be on site at the same time, but at one point they will all be needed. So that's why we figured on 3 crews. So that gives a brief overview of the whole project with the 4-month schedule, the $3 million bottom line, and the finished look of the wall.
For our recommendations, we recommend that Michigan Tech get another soil boring test done. The previous one was done in 1995, so a few years back now, and it was also done a little bit east of the project site right now. So we recommend getting that done on our actual project site, just so we know for sure what we're working with the ground surface below. We also recommend that all utilities be marked out prior to construction. This way we just know where everything is at, and we're not running into anything due to not knowing its location. We also recommend that all scheduling will go through the university, as well as be coordinated with the H10 building construction. And this again, just getting ahead of it and making sure we're not running into any interferences that we do not need to.
All right, and then there's another overview of the project to leave you with, and thank you for joining us today. Any questions?
I started a little late, so maybe I missed it, but does this path meet ADA requirements?
It does not.
Not.
Okay.
I believe it's just slightly off. So the required length of the path would increase significantly if it would. So it would lead out relatively much farther up the hill than what would be desired, because you'd have to go up the hill to get to the path to meet the slope requirements.
We looked at the option of a switchback, but with the landing in place, but it just takes up, there's not enough space there, unfortunately, So it is something that could be developed, but it will have quite a bit of added cost and time for planning there. Great question.
I got another question. If you go back to your groundwater
Mhm.
slide. Okay, you're assuming that the groundwater elevation is flat. And I think that assumption you cannot make. You have no idea what you're gonna encounter once you start digging things up.
Mhm.
You may encounter springs. I don't think you're gonna have problems, but it doesn't mean you're not going to.
Yes.
Did you look at any of the groundwater data from the borings, those 3 borings that were done down?
Yeah, they were both like right around 600 feet. The ones up on top were, I want to say like 601 or 602, and the one on the bottom was like 600 or like 598.
Yeah, so that gives you a good indication. Now, when you're doing your borings for this project, how many borings do you think you're gonna need?
That's a great question. My assumption coming into it pretty blind would be 4 in total across like a quarter of the path, kind of section it out. Just to kind of get the full feel of the overall width of the path.
That's probably pretty reasonable. How deep do you think you should go?
You probably want to find that groundwater, right, to make sure that we're not in it. So if we're roughly thinking it's about 600, yeah.
You want to make sure that you're not gonna encounter anything crazy.
yeah,
Mhm.
across the
How
cut.
deep are your piles?
So it'd be 10 feet below the surface, so roughly 25 feet is the overall length. The lower one might, by the time we cut that down 15 feet, it'd probably be about 17 feet down below the surface level
Yeah,
max.
so if your borings are 25 feet deep, you should.
Okay.
So. For me.
Thank you.
Maybe, I don't know if you remember comments, so it's like 27. So before the total cost was below. And the total cost, 1.8, this was 3. I wonder if you could comment on the difference in cost.
Yeah, so I was thinking about that when I was actually sitting through the presentation, expecting a question similar to this. So when we're looking at our overall breakdown, I believe our contingency is larger than theirs just because we had more involved in it. I don't believe they took equipment into account. Possibly they did in the constructability of the wall, but we did as well. But the overall site development, including the leveling of the slope of the hill and stuff for the constructability of the wall, is something that we had in the pre-site, including the clearing and so forth. So I think our equipment cost is considerably larger than theirs, as well as our wall costs. And you saw that in our evaluations, close to $1 million. I believe theirs was closer to 600,000. That precast finish just adds a lot to the overall wall cost design. We also use the estimate. What's that?
How much do you think that precast adds?
It adds about 200,000
$200,000.
to the overall layout, just with adding it on, right? Just the putting it on and placing it and having the work involved with it. We also assume for our wall, and we know this assumption is wrong, just with the overall, we said there was a 15-foot cut across the entire duration of the path. It's not going to require a 15-foot cut, right? So you're going to lose value in our estimate based on the material cost that's going to be required for the wall, as well as just the time and labor involved in the constructability. So I think our overall wall design, you might see that value drop closer to that 800,000, 600,000 valuation that's included. Yes, it's a very conservative estimate,
Yes.
so it's within reason to what to expect, but I shouldn't say it's wrong, correct, but
I also believe they have fewer crews that I don't know how they necessarily calculated what they based off from. I mean, it's a minor item, but it definitely adds
Yeah.
up to the overall total. So I know we have 3 crews. At one point, I think they were looking at one crew, so.
and by the time you add light fixtures in and barrels and signage and all of that adds a couple $1,000 here and there, $100,000 eventually, and
We also
into the
had
million.
like the signage, we had the signage and we included, the drainage costs and that, we included it in those prices. I think they just had their site layout, and we had the signage detour added to.
Yeah, it definitely would be interesting to look at how much of a breakdown they had on those items.
Yeah, so I think overall, the estimates are comparable if you scale it to the overall scope, including the retaining walls. So,
And does yours include the stormwater cost as well?
Yep.
it does.
What's the retainage cost?
It's a great question. I couldn't tell
wanna
you
say
the
it's
overall percentage that we had right off the top of my head. That is in our final report. You can see the estimate breakdown.
It's not a ton.
It's not a lot. I want to say 10,
Yeah.
maybe
I would say
10%.
10%.
Because typically retainage is money that's withheld during the period of construction to the very end.
Yep.
It's not additional cost on the project.
Okay.
So
Okay.
that estimate, like, yeah, that
Yeah,
could
so
be
that's 10%.
reevaluated in our overall breakdown. That's a great point. Thank you for that.
Nice job.
Thank you.
Should I
Thank you for
stop
this opportunity.
recording?
It was a lot of fun to work on it this semester.
Okay.
It was a cool project, close to home.
Yes.